Science Olympiad Class 8. Force and Pressure.
Introduction. Actions like picking, opening, shutting, kicking, hitting, lifting, flicking, pushing, pulling are often used to describe certain tasks. Each of these actions usually results in some kind of change in the motion of an object. In science, a push or a pull on an object is called a force. Thus, we can say that the motion imparted to objects was due to the action of a force. Force due to interaction. The figures show three situations that may be familiar to you. Can you decide who is pulling and who is pushing in these cases? In figure A, both the girls appear to push each other. In figure B, the pair of girls are trying to pull each other. Similarly, the cow and the man in figure C appear to pull each other. The girls in the two situations shown here are applying force on each other. It is also true for the man and the cow. From these examples, we can infer that at least two objects must interact for a force to come into play. Thus, an interaction of one object with another object results in a force between the two objects. A force can change the state of motion. For example, while taking a penalty kick in football, the player applies a force on the ball. Before being hit, the ball was at rest, and so its speed was zero. The applied force makes the ball move towards the goal. Suppose the goalkeeper dives or jumps up to save the goal. By his action, the goalkeeper tries to apply a force on the moving ball. The force applied by him can stop or deflect the ball, saving a goal being scored. If the goalkeeper succeeds in stopping the ball, its speed decreases to zero. These observations suggest that a force applied on an object may change its speed. If the force applied on the object is in the direction of its motion, the speed of the object increases. If the force applied in the direction is opposite to the direction of motion, then it results in a decrease in the speed of the object. A force can change the state of motion. Let us consider some more examples. In a game of volleyball, players often push the moving ball to their teammates to make a winning move. Sometimes the ball is returned to the other side of the court by pushing or smashing it. In cricket, a batsman plays his or her shot by applying a force on the ball with the bat. In all these examples, the speed and the direction of the moving ball changes due to the application of a force. A change in either the speed of an object or its direction of motion, or both, is described as a change in its state of motion. Thus, a force may bring a change in the state of motion of an object. Force can change the shape of an object. The following animations prove that the shape of the objects changes by force. A lump of dough on a plate, pressing it down, spring fixed to the seat of a bicycle by sitting on the seat, a stretched rubber band by pulling its free end, a plastic or metal scale placed between two bricks by putting a weight at the center of the scale. Results of applying force may make an object move from rest, may change the direction of motion of an object, may bring about a change in the shape of an object, may cause some or all of these effects. Contact forces. Animals also make use of muscular force to carry out their physical activities and other tasks. Animals like bullocks, horses, donkeys, and camels are used to perform various tasks for us. In performing these tasks, they use muscular force. Since muscular force can be applied only when it is in contact with an object, it is called a contact force. Friction. When we stop pedaling a bicycle, it gradually slows down and finally comes to a stop. A car or a scooter also comes to rest once its engine is switched off. Similarly, a boat comes to rest if we stop rowing it. In all these situations, no force appears to be acting on the objects, yet their speed gradually decreases and they come to rest after some time. What causes a change in their state of motion? Could some force be acting on them? The force of friction always acts on all the moving objects and its direction is always opposite to the direction of motion. Since the force of friction arises due to contact between surfaces, it is also an example of a contact force. Non-contact forces. Take a pair of bar magnets. Place the longer side of one of the magnets over 3 round-shaped pencils or wooden rollers as shown in the figure. Now, bring one end of the other magnet near the end of the magnet placed on the rollers. Make sure that the 2 magnets do not touch each other. Observe what happens. Next, bring the other end of the magnet placed on the rollers. Note what happens to the magnet placed on the rollers every time another magnet is brought near it. Like poles of 2 magnets repel each other, and unlike poles, attract each other. Attraction or repulsion between objects can also be seen as another form of pull or push. A magnet can exert a force on another magnet without being in contact with it. The force exerted by a magnet is an example of a non-contact force. Electrostatic force. Take a plastic straw and cut it into nearly 2 equal pieces. Suspend one of the pieces from the edge of a table with the help of a piece of thread. Now, hold the other piece of straw in your hand and rub its free end with a sheet of paper. Bring the rubbed end of straw near the suspended straw. Make sure that the 2 pieces do not touch each other. What do you observe? Next, rub the free end of the suspended piece of straw with a sheet of paper. Again, bring the piece of straw that was rubbed earlier with paper near the free end of the suspended straw. What do you observe now? A straw is said to have acquired electrostatic charge after it has been rubbed with a sheet of paper. Such a straw is an example of a charged body. The force exerted by a charged or uncharged body is known as electrostatic force. Gravitational force. You know that a coin or a pen falls to the ground when it slips off your hand. Leaves and fruits also fall to the ground when they get detached from the plant. Have you ever wondered why it is so? When the coin is held in your hand, it is at rest. As soon as it is released, it begins to move downwards. It is clear that the state of motion of the coin undergoes a change. Can this happen without a force acting on it? Which is the force? Objects or things fall towards the earth because it pulls them. This force is called the force of gravity or just gravity. This is an attractive force. Water begins to flow towards the ground as soon as we open a tap. Water in rivers flow downward due to the force of gravity. Pressure. Try to push a nail into a wooden plank by its head. Did you succeed? Try now to push the nail by the pointed end. Try cutting vegetables with a blunt and a sharp knife. Which is easier? Do you get the feeling that the area over which the force is applied, for example, the pointed end of the nail, plays a role in making these tasks easier? The force acting on a unit area of surface is called pressure. Pressure is equal to force divided by the area on which it acts. Pressure exerted by liquids and gases. Take a plastic bottle. You can take a soft drink bottle. Fix a cylindrical glass tube a few centimeters long near its bottom as shown in the figure. You can do so by slightly heating one end of the glass tube and then quickly inserting it near the bottom of the bottle. Make sure that the water does not leak from the joint. Cover the mouth of the glass tube with a thin rubber sheet. Now, fill the bottle up to half with water. What do you observe? The rubber sheet fixed to the glass tube bulges. Pour some more water in the bottle and the rubber sheet bulges. Note that the rubber sheet has been fixed on the side of the container and not at the bottom. The bulging of the rubber sheet in this case indicates that water exerts pressure on the sides of the container as well. Pressure exerted by liquids and gases. Take an empty plastic bottle or a cylindrical container. You can take a used tin of talcum powder or a plastic bottle. Drill 4 holes all around near the bottom of the bottle. Make sure that the holes are at the same height from the bottom. Now, fill the bottle with water. What do you observe? The different streams of water coming out of the holes fall at same distances from the bottle. We say that liquids exert pressure on the walls of the container. Gases exert pressure. When you inflate a balloon, why do you have to close its mouth? What happens when you open the mouth of an inflated balloon? The air is let out. We say that air exerts pressure in all directions. Gases too exert pressure on the walls of their container. Atmospheric pressure. There is air all around us. This envelope of air is known as the atmosphere. The atmospheric air extends up to many kilometers above the surface of the earth. The pressure exerted by this air is known as atmospheric pressure. Atmospheric pressure. The measurement of atmospheric pressure was demonstrated by Otto van Guericke in the year 1654. He used 2 hollow hemispheres as shown in the figure with a leather gasket in between them to make them airtight. Through a small outlet in one hemisphere, the air was completely removed using an exhaust pump. When he tried to separate the hemispheres, he could not do it because of the vacuum inside the sphere, and finally they had to use nearly 8 horses on each side to separate them. This experiment proves that air exerts very great pressure.